After setting up the project, we have the raw data from the COVID-19 repository, which is not necessarily updated. At the same time, make sure we have activated the virtual environment. Before the dashboard session starts, the main script appful will update this local copy using git, and followed by some data processing, as you can see. Then the dashboard application starts up. By the way, there are 186 countries that we can choose from for the dashboard. So now let's take a look. So this interactive plot depicts how many cumulative confirmed cases were for a given point of time for those selected countries. You can easily remove some countries and add some new country, and you can see the callback at the background will update this plot. But the cumulative plot is arguably not very meaningful. We might want to instead know how many people are infected at a given time, or we may even want to predict the future trend for resource planning, etc. And this is somewhat addressed by part 2, which is based on a rather simple SIR model. And there are several things we can do with it. First, we can plot the so-called empirical number of infected people and the removed people, which is this option here, as a time series. Then we can also normalize the y-axis to allow apple-to-apple comparison between countries. And additionally, we can identify the SIR parameters for the countries and the so-called observation period specified here. And this allows us to predict the future trend to some extent. Now again, we can plot the simulated time series on the same graph. And now we can zoom in, and any changes to these settings will be automatically updated to the plot. And this is what here is all about. And last but not least, the parameters like the contact ratio can also be very interesting to us. You can interact with this table, you can sort it by those values, and sometimes the data may be somewhat corrupted, or the SIR model assumptions are violated, or even both. So for this reason, we have some primitive possibility test. The result will be reflected in this yellow warning message, as well as the orange color in the corresponding rows. So now for the rest of the video, let me explain you how I organize the application. So during the initialization, the dashboard application invokes the data update functions, which fetches the latest data from the repository, then computes the time series of the measured number of removed and infected people, SIR_R and I. And after that, two callback functions react to the changes in the country selection and send the relevant data to the corresponding GUI widget. The second part is not just about plotting the empirical time series as you saw before, but also identifying the key parameters, which we also mentioned. So all these are made possible by the SIR module, and everything starts with the continuous time function, and with that we can obtain the simulated time series of the number of infected people. We will also use these functions for the posterior or so-called batch fit, and this is done inside the sysid function. To facilitate the optimization process, it is absolutely essential to provide some proper scaling and initial guess, and this is what estimate varying beta gamma function means for. All these functions are self-independent, highly modular and reusable, and building on top of that is the function SIR countries, which provides the ideal granularity for the dashboard applications. And the two data frame outputs, these two data frame country info on SIR and data frame SIR eyes movement and predict, correspond exactly to the GUI widgets in the part 2. Unfortunately, there isn't enough time for me to cover other aspects like memorization and how the optimization works. But if you are interested, please feel free to visit my repo, and thanks for watching.